Alright guys, so now we are going to work on this lecture 5.4, sum and difference identities for sine and tangent. You should be able to work with the sum and difference identities to find exact value of additional angle and simplify expression involving the sine or tangent of a sum or difference of an angle. So that is what you need to keep in mind. So you have two formula, and let me prove you that sinus A plus B equals sinus A cos B plus cos A times sinus B. We could do exactly the same for sinus A minus B also. So if you look at sinus A plus B, you know that's going to be equal to cosinus 90 minus A plus B. We have seen that already in a previous section. Therefore, using one of the sum and difference identity for cosine, I'm able to write cosinus 90 minus A cosinus B plus sinus 90 minus A sinus B, and that implies that sinus A cos B plus cos A sinus B. So that is my proof. But at the end of the day, if you're not able to remember how to prove it, that's okay, because you will have that on a flashcard. But it's a good exercise, and I will advise you, even though you could just copy what is written right here, to do it by yourself first and then try to understand each step. Same idea for tangent A plus B. You have the proof, but the idea is to understand when I use my sum and difference for sine and cosine, I end up to have this first fraction right here. Why do I divide top and bottom by cosinus A cosinus B? Well, it's to transform the sinus A cos A into tangent and sinus B cos B divided by cos B into tangent of the angle B. And that is going to help you to express tangent A plus B only with tangent A or tangent B. So now, let's work on this example, practice number 1, sinus of 15 degree. Well, you are going to try to transform 15 degree into the sum or the difference of two angles that you can find on your trigonometric circle. Therefore, 15 is 45 minus 30. And so sinus 15 equals sinus 45 minus 30. Then you apply the formula that you need to work with, and you will be able to find the value of sinus 15 degree. Same idea for the tangent. In that case, we are not dealing with an angle written in degree, but an angle written in radian. So you have to transform 11 pi over 12 into the sum or the difference of two angles, multiple of pi, but also reminding you angle that you have in your trigonometric circle. Therefore, 9 pi over 12 plus 2 pi over 12 give you, when you simplify these two fractions, into 3 pi over 4 plus pi over 6. Sorry for that. And so you will just have to apply the formula that we just give a proof above, and you will be able to find the answer of tangent 11 pi over 12. You can always use your calculator, but we are not looking for you using your calculator. We are looking for you to be able to express the value of tangent 11 pi over 12 by using the formula you have above. This is why you have the example number C. On the example number C, the only thing what we are asking you is to realize that what you have in front of you is mainly tangent of 100 degree minus 70 degree, which is basically tangent of 30 degree. And by using your trigonometric circle, we end up to have tangent of 30 degree equal 1 over square root of 3. If you want to rationalize your denominator, you may want to multiply top and bottom by square root of 3 to get rid of the square root on your denominator, and you end up to have square root of 3 divided by 3. Alright, let's move on to the next problem. Write each function as an expression involving function of theta only. Well, if you're looking at the definition of sinus A minus B, A minus B being equal to theta minus 270 degree, you end up to have, let me use my blue marker, you end up to have sinus of the angle theta multiplied by the sinus of 270 minus cosinus of the angle theta times cosinus of 270 degree. Sinus 270 degree equal -1, so I end up to have sinus of the angle multiplied by -1 minus cosinus theta multiplied by 0, because the cosinus of 270 degree is 0, and therefore the answer of sinus theta minus 270 degree is equal to negative sinus theta. Now, we're having tangent theta plus 3 pi. I would advise you to graph, and I'm going to do it for you. I'm going to do it by hand. What I would suggest is understand what is 3 pi and where we at when we're doing 3 pi. So what we are going to do is 1 pi. Let me take another 2 pi. And finally, 3 pi. So when I am at 3 pi, when I'm doing theta plus 3 pi, what is tangent 3 pi? Well, tangent, at some point you will have to deal in your formula, and please, I want to see that on your paper. So in your formula, at some point you are going to have tangent 3 pi, and what is the value of tangent 3 pi? Work on that, and you will be able to find very easily the expression of tangent theta plus 3 pi. Same idea for sinus 120 plus theta. Express what is the sinus of 120, and you will be able to express the sinus 120 plus theta only involving function of theta. What I can do also for this problem, it is showing you that when you are at 120 degree, you are in a quadrant 2. That is an angle of 120 degree. That shows you that the value of the sinus will be positive and the value of your cosinus will be negative. Therefore, the value of a tangent, by example, will be negative. So I'll let you do that by yourself, and let's try to do problem number 3. So suppose that cosinus of the angle A equal -7/25 with angle A in quadrant 3. That is to help you to define what value of the sinus you will looking for. And same thing for sinus B equal -3/5 with an angle B in quadrant 4. So, first of all, in order to find sinus A, sinus B, which is equal to, like to remind you this, sinus A, sinus B minus cosinus A, cosinus B, I realize that if I want to find the value of sinus A minus B, I need to know the value of sinus A and the value of cosinus B. Well, I know that sinus square of the angle A plus the cosinus square of the angle A equal 1. I know the value of cosinus A, so I can express sinus square of A equal 1 minus cos square of A. I take the square root, therefore I'm ending to have plus or minus square root of 1 minus cos square of the angle A. Because I know that I am in quadrant 3, my sinus is negative, sinus A is negative because quadrant 3, therefore sinus A equal negative square root of 1 minus cos square of A. Let's try to do the same thing for, so I'll let you calculate the sinus A by substituting cos A by -7/25, and you will be able to find and use it in your formula. Let's try to apply exactly the same process for the angle B. Sinus square B plus cosinus square of the angle B equal 1. But this time what I'm looking for is cos. So cos square of the angle B equal 1 minus the sinus square of B. And if I take the square root, I end up to have cosinus of the angle equal plus or minus the square root of 1 minus sinus square of B. Because I know that I am in quadrant 4, the cosinus is positive. Cosinus of B is supposed to be positive because I am in quadrant 4. Therefore, the cosinus of B is going to be equal to plus 1 minus sinus square of B. I'll let you substitute the value of sinus B and cosinus B in this expression, and I'll let you find the value of sinus A and sinus B as a fraction, and then you just need to apply the definition of sinus A minus B to find the value, the expression, the value, of sinus A minus sinus B. Let's do the problem number B. Tangent A minus B. Well, I know that tangent A minus B, it is basically sinus A minus B divided by cosinus A minus B. Because I know the value of sinus A, sinus B, cosinus A, and cosinus B, I can totally substitute the value inside this formula by transforming sinus A, sinus B, and cosinus A, cosinus B, and I will be able to find the value of tangent A minus B. Now, the quadrant of A minus B. What is the quadrant of the angle A minus the angle B? Well, first of all, I know that the sinus of A minus B is greater than 0, and I know also that the cosinus of A minus B is greater than 0. What does that mean? It means that basically A minus B is in quadrant 1. If you look at here we go, quadrant 1, quadrant 2, quadrant 3, quadrant 4, the cosinus are positive right here, and I'm going to use, there we go, I'm going to use this right there. So right there we're having a cosinus positive. Then right here we are having a sinus positive. Then right here we have the cosinus which is negative. And finally, let me take another color. Let me take the blue. Right here we're having the sinus negative. So in blue, let me erase that, change my pencil. So in blue we're having the sinus negative. In red we're having the cosinus of an angle positive. Let's call that the angle theta. Okay, right there, theta. While in green I have the sinus of the angle which is also positive, and in purple, so I hope I have the right color, but you will understand. In purple, I have the cosinus of my angle, which is negative. All right. So now in this last example, first use the tangent of a sum of difference to express tangent pi over 4 plus t and tangent pi over 4 minus t. Second of all, substitute tangent pi over 4 by its value. I'll let you do that. Then you need to rewrite both equations with the same denominator. So you will have to find the LCD. Let me put at least a S2 equations. You need to remember that you might have to make reference to algebra. So you have different relationships that you need to use. I'll let you finish this problem, and I will see you in class. You have everything.